Thank you guys for inviting me to this webinar. My name is Luca Olivari. I'm the president of OrientDB. I joined the company about 6 months ago from MongoDB. Before, I've been working at MySQL, Oracle. So I've been in the database industry for a while now. I'm going to run you through an introduction to OrientDB and then hand over to the KeyLines guys to understand why we decided to partner together, why it makes sense to use OrientDB together with KeyLines technologies. So what is OrientDB? In a single statement, OrientDB is the leading multi-model database. It combines the flexibility of documents with the connectedness of graphs and the familiar SQL dialect. A lot of things to digest in this statement, but basically multi-model databases are now becoming mainstream. And the idea is to marry a few different types of NoSQL solutions and then create multiple APIs to connect to the database itself. So a few words on the company. We are present globally. We have offices in the US, we have offices in Europe, we have offices in APAC, more than 140 enterprise customers, thousands of users, including Fortune 10 and Fortune 500. We are an open source company, so we believe in the importance of community. We don't do everything alone. We actually have more than 100 people who are contributing to our code. We have 50,000 commits, 70,000 downloads per month, more than 7,500 students on Udemy, and 8,000, now 9,000 followers in total. We've been covered recently by the press. We won the Bossy Award. For those who are not familiar with that, is the Best of Open Source Software Award by InfoWord. We've been covered by Tech Republic, InfoWord, and people are starting to realize how important it is to use more and more technologies together. So it seems that nowadays everybody is starting a database company. So there are more than 300 database companies out there. Some of them are solving just a portion of the general problems that are faced by developers and that are faced by DBAs. Some others are more general purpose. And what we try to do with this quadrant is basically to clarify how OrientDB fits into this panorama of 300 different solutions. So on the x-axis, you have the complexity of data. On the y, you have the complexity of relationships. So let me start from the left to the right, from the bottom left quadrant, where you see key value stores. Key value stores are, let's use some names. Let's say Redis. Extremely scalable, extremely fast, but everything you can do is read and write a key and a value. So really, really simple piece of technology that can be used in some use cases, but not everywhere. If you move to the right, you have wide column stores like Cassandra, for example. And Cassandra allows you to model a bit more complex data and a bit more complex relationships. So you have this concept of wide column where you can have or not a column. You can expand the table as much as you can. But again, very scalable, particularly for writing-intensive applications, but not really good to manage complex data or relationships. If you go on the top left quadrant, you have graph databases. Again, let's say Neo4j, for example. Fantastic technology that allows you to model complex relationships, but again, relationships are nothing without data, and data is nothing without relationships. So graph databases are very complex, but they don't solve all the issues. If you go on the bottom right quadrant, you have document databases like MongoDB, my previous employer. And they're very, very good at managing complex data. So you can store in a JSON document pretty much everything you want, but connecting JSON documents between them is going to be pretty challenging. On the top right quadrant, which is where everybody wants to be, you have relational databases. And actually, you can argue that relational databases have been so successful in the last 45 years because they allow you to model a lot of different domains. So you can Relational databases are general purpose, so you can write an ERP, a CRM. You can even build a social application on top of a relational database. You can build a web-based application, or you can build an on-premise application. You can build it in the cloud, and so on and so forth. But they've been designed and created at least 45 years ago. So all technology based on something that is not scalable for today's data. The idea of the founder of OrientDB, another guy called Luca, was to marry graph and document databases together and create the first ever multimodal database. So in OrientDB, you have a graph interface and you have a document interface. So to say that, in other words, OrientDB is a graph database where every vertex and edge is a JSON document. So as you can see in this slide, you have John who is ordering an iPhone. And that's fine. That can be modeled easily in a graph databases as well. But what you can do with a multimodal solution is also to attach a JSON document to every vertex and edge. So the properties of John is part of the class people. His first name is John, his last name is Power, and you can even embed a JSON document within the document that's describing John. And the same is true for the orders part, and the same is true for the iPhone part. So as you can see, the graph layer allows you to connect different types of data very, very easily. And the document interface allows you to describe with sophisticated JSON documents every vertex and edge. Why graph databases underneath? So why should we use the graph theory? Well, relational databases, as I said before, have been really, really successful in the last few years. But, well, if you use a relational database when you want to connect your customers with their addresses, you need to use the normalization theory, and you have to create a customer address table. So every time you traverse from customer to address, you have to create a join. And joins are executed at runtime. So every time you cross the relationship, the join is executed. And that can slow down significantly the performance of databases. So everybody who is familiar with relational knows that the best way to make a relational database fast and scalable is to try to limit joins. But today's data is extremely connected. Every type of application nowadays has a social component. So if you're building a CRM, chances are there is a social component. If you're building an ERP, chances are there is a social component. Everything we do needs to have more and more connected data. So the difference with graph databases, if I go back to the slide before, is that relationships are direct pointers that are not created at runtime. They are created when you put your data in. So the connection between John and the iPhone, the fact that he's ordering an iPhone, is created it's created when you insert the data, and when you query it, the cost of traversal is constant. So no matter if you have 10,000 rows or documents, to use our language, or a billion documents, the traversal time is always constant. That's really key. So what are the benefits of OrientDB? It's easy to learn and based on standard. We use the SQL interface, we use Thinkerpop, which is a standard for graphs. You can query OrientDB from the REST interface. You can use JavaScript. You can even use JDBC and connect OrientDB to any other tool available on the market. It's very easy to develop with OrientDB. We have data validation, we have rich queries and rich data model, and everything can be put into a JSON document. But that's not enough. It's easy to grow and operate. So you can easily scale out on commodity hardware. We have a multi-master architecture, and most of the operations are online. So you can start with a single node and then move to multiple nodes, scaling horizontally without having to change any single line of code. And we have a lot of features like transactions, sharding, auditing, and so on and so forth. And if you're familiar with Python, you can build applications from Python. If you use Java, use Java. If you want to use Scala, Ruby, .NET, Node.js, whatever, we have a client for OrientDB. So in terms of safeguarding your data, OrientDB puts a lot of effort into making sure the database never goes down. So we have built-in high availability functionalities. So when your clients are writing to one node, they can easily fail over to the other node because there is a multi-master replication in place. So you don't lose data. You can easily create a cluster, an highly available environment without adding any complexity to the layer. And we have ACID transactions. So every transaction is atomic, consistent, isolated, and durable. And they can be done on multi-statements. So you can process multiple documents together as if they were one. Then scalability and performance is another area that's really, really interesting for us. You can, as I was saying before, you can start with a single node and then move to multiple nodes. And OrientDB will distribute the workload over them. And there is an auto-discovery mechanism whereby when you connect a new node, it tells to the cluster that is there, and then it grows basically the scalability of the underlying infrastructure. To give you some numbers, you can easily handle 200,000 transactions per second on commodity hardware. And imagine how many you can handle if you scale horizontally, if you add more and more nodes. What are the use cases for graph databases or in general for multi-model solutions? Well, these are the 9 largest ones, but there are more and more. In the KeyLines part, we'll focus on stuff around network management or security and fraud management, but you can build pretty much everything around OrientDB. A few interesting ones, Bitcoin and blockchain, for those who are familiar with what's happening in the financial service industry. Everybody's trying to use blockchain as a technology to disrupt how banks are doing business. Or geolocalized applications, or if you want to route somebody, let's say you're using Google Maps and you want to find the easiest path between point A and B, well, you can easily create a graph to describe the problem. Other cases, network management, recommendation and e-commerce, for example, is pretty interesting. So if you want to build a recommendation engine, then a graph database could fit the bill perfectly, but not just a graph solution, because you don't really need to manage only the relationships, but you also need to store data. So if you are an e-commerce, you can start to put your relationships in OrientDB, then move the content to OrientDB using the document functionalities, and then third step, you can build an entire e-commerce on OrientDB. Security and fraud detection, another interesting use case. Real-time analytics. OrientDB is not really an analytical solution in a strict sense of the term. It's more an operational database, but the analytical part can be easily solved. And customer content management, as I mentioned before, or single view of everything. In just a few words, with OrientDB, people are building really, really new, highly visible and valuable applications that require a new solution. So we don't really encourage people to migrate from relational to OrientDB. We tend to address the new projects, those where you need new technologies that are better suited to solve the problems you are trying to address. And it's not enough. I mean, graph databases are growing exponentially. Forrester is predicting that 25% of Fortune 500 of large enterprises will use graph databases in the next 2 years. On dbengines.com, graph databases increased their popularity a lot, and it's actually the fastest growing category in the NoSQL world. And amongst the top 50, OrientDB is the technology with the largest year-on-year growth on DB engines. So we're pretty happy about what we've done so far, but we see a huge growth everywhere. But that said, OrientDB is just a piece of technology. It's just a database. We don't really provide the rich visualization capabilities. We don't really provide BI, business intelligence functionalities. And if you want to extract value from connected data, you have to visualize it. And that's why we partner with KeyLines. So the idea of the partnership, and then you can find the press release on our websites, but the idea is really to make the power of KeyLines available to everybody who is using OrientDB. So you don't just store your data, you don't process your data in OrientDB, but you can visualize it in a very rich and compelling fashion using the KeyLines technology. And that's basically it on my side. So I'll hand over to Jeremy for the KeyLines part.
Yeah, thank you so much, Luca. Thank you for the handoff, and thank you everyone who's attending our session today. My name is Jeremy. I'm the Director of Business Development here at Cambridge Intelligence. I want to remind you that on this webinar, you can definitely send questions across. Within the GoToWebinar control panel, you should see a space for typing in your questions, and we'll receive those, and we'll try to make sure that we save some time for Q&A at the end. I do apologize in advance if we're not able to get to your question because of time constraints, or if we feel that it's best to answer you one-on-one offline. We'll try to make sure we reach out to you after the webinar and follow up. So I'm going to talk today about some of the core principles of network and graph visualization. I'm going to show you some of the key features of KeyLines and show you areas where KeyLines can really help you to take advantage of the multi-model approach that Luca described for OrientDB. First, a quick word about our company. Cambridge Intelligence, we were founded in May of 2011. We make tools to visualize networks. Specifically, we make a product called KeyLines, which I'm sure you've heard referenced a few times already in the webinar today. I'll tell you more about that in detail. And for those who are wondering, the Cambridge in our name does refer to Cambridge, UK, despite my American accent. We are very proud to also be a company with customers across many, many different industries, as well as many, many different countries and customers on 6 continents. So what is KeyLines? KeyLines is an SDK, a software development kit, that bundles a component for web application designers to embed visualization applications and capabilities to their end users. So let's think about that for a second. What that really means is that KeyLines is designed for you, the developer, to take data from a source like OrientDB and create meaningful, rich visualizations that your customers, which could be, for instance, analysts, business analysts, business intelligence teams, managers, and so on within your organization, and consume those visualizations and learn from the data. First, I want to help understand why KeyLines is important as opposed to using something like the OrientDB graph editor. The OrientDB graph editor is a tool that comes with OrientDB, and it's designed for developers and data architects to understand, manipulate, and explore the data model. So what does that mean? It means it's really a tool that bundles capabilities for designing the way that data is stored within a database and manipulating that. Of course, that's very powerful, but perhaps too powerful for some end users. This is where a tool like KeyLines can come in. KeyLines is a customizable tool that allows you from the development side to create these visualization applications and cater them specifically to the different audiences that you might have, while removing some of the complexity of manipulating the data model. So, on a technical level, what is KeyLines? KeyLines is a JavaScript library for building visualizations. It's fully customizable, meaning that with KeyLines, you have the ability to customize or tailor all the individual aspects of a visualization layer in order to suit your specific needs. KeyLines renders in HTML5 with full cross-browser support, and for those who need it, perhaps stuck on older editions of Internet Explorer, KeyLines does also bundle a flash fallback feature. Let's talk a little bit about the architecture of KeyLines. So KeyLines, as I mentioned, is a JavaScript library that produces an HTML5 output. So that means that KeyLines is actually designed to run within a browser. Now, in the pages that call KeyLines visualizations, you'll typically have an AJAX request that is communicating with the data backend over a query language like SQL or Tinkerpop, returning a result set back in a JSON format that KeyLines can then consume and render in the browser into the visualization layer that the users will see. Why do we do visualizations? Let's talk about that for a second. Visualizations fundamentally are designed to help you, yes, understand the structure of the data, but that's, again, not quite enough. Beyond understanding the high-level structure, very often you'll need to dig down into the data itself to see individual relationships that help you understand what's actually happening with, for instance, the customer data that's represented in your data set, or whatever it may be. All of that is to say, in sum, the purpose of visualization is to help end users extract insight from the data. And that's really where visualization can play a critical role in helping you to get the most out of your data stores. Now, Luca talked about some of the use cases for OrientDB, and many of them are similar use cases to what we see for visualization customers. We're going to go into some demos in a few minutes that highlight some of these areas, but you'll see, for instance, that cybersecurity is also a core use case for KeyLines customers, as well as process and infrastructure management, anti-fraud, and others, including geospatial routing and awareness. When we're creating visualizations, it's important to keep in mind some of the core guiding principles, some of the basics that we need to remember while we create those visualizations. Visualizations should be designed with visual clues in mind, helping the users to find that insight quickly. So what that really means is we would like to manipulate the aspects of the visualization in order to guide the end user, the consumer of the visualization, towards either naturally occurring patterns or key elements in your data. Sometimes these are dense patterns, sometimes these are outliers. We'll see some examples of those in the demos. But basically, visualizations are designed to help you narrow your focus from potentially a very broad set of data down to the data that is of core interest to you. How do we do that? Primarily, we do that by manipulating the visual properties of the visualizations. So Luca mentioned that the graph model is one that talks about nodes and edges, which is to say data elements and the relationships that connect those data elements, or data points, if you will. In this model here, you can see different data nodes and the edges that connect them. With visualization techniques, what we want to do is we want to manipulate the display of those elements in order, again, to guide us towards the elements that are of most interest to us. So with that, I'm going to jump out of the presentation and into some demos. Bear with me one moment. Great. So the first demo that I'd like to show you is actually a demo that bundles KeyLines together with OrientDB. Now in this data set, what you'll see is, of course, the brand Porsche, very prominent here in the middle. And we've got a data set that includes some information about Porsche customers, Porsche models, and prices of different Porsches. So in a typical graph exploration, what we can see is that we very often would like to extract more and more information. So we start from a base of some set of data and some relationships between it, and we might want to, for instance, double-click and add more data, understand what are the options available with the Cayenne S hybrid. So with this demo, what you've probably noticed already is that every time I double-click on an action, we're creating an additional query to go back to OrientDB, ask it for additional data that's related to the item in question, and bring that back into the graph. Now you'll notice that while I'm adding data to the visualization layer, what's happening is that it's starting to change the shape of my visualization. Now what I can do, if I'd like to kind of clean this up, is I can select a different element and I can tell KeyLines to lay this out in a different manner. That can help me, depending on what it is exactly that I'm looking for, to again get a visual sense for what is most important in this. So for instance here, if I'd like to understand the hierarchy of Porsche with its customers and models, I can do that. Next, I'd like to talk about visualizations for some of the cybersecurity use cases that Luca was mentioning. Just going to zoom in so we can explore the data in a little bit more detail and understand. You'll notice that these are all phone numbers. This is a data set that contains phone calls made between individuals over a period of time. So you'll notice that we're leveraging not only the connections between the people in this data, but we're also leveraging the time element, because a phone call, of course, happened at a particular point in time. So that's, again, taking advantage of different properties or attributes of our individual, of our edges, and using those to create the visualization. Very often what we find is that it's actually the connections between the data that are most relevant for us. So we can see, for instance, if we zoom this out for just a moment, we can see that right here, we notice one group of people that is connected to the rest of the group by only a single person or a single phone call. Let me just tweak this one moment. And again, you'll see, here I have an entire group that is only connected by a single phone call to the rest of it. And by, again, examining at the deeper temporal level, seeing when these calls happened, we notice that they happened only at the very beginning of the time period in question. So as we're exploring this data set, for instance, we notice that this behavior doesn't match what's happening at the center of almost any of the other kind of groupings of people, the naturally occurring patterns, again, in our data, where we're seeing that there is a steady stream of phone calls happening and that each kind of individual network is connected to multiple other networks within this data set. So that's, again, where visualization can help us zero in on the data that we're most interested in. Next, I'd like to showcase a little bit more about some of the different elements that we can, some of the different techniques that we can use with visualization. So this is a data set that some of you may already be familiar with. These were emails sent between Enron employees that became public during the lawsuits after the collapse of Enron. So one thing that we can do, again, is we can use information about how frequently people have emailed each other, or the total volumes of emails sent, to change some of the sizings. So here you'll notice as we turned on the email volumes, several lines, several edges became much thicker, and that is showing the volume of emails sent between those individuals, as well as the direction sent from one person to another person. We can also use a number of social network algorithms to understand things like betweenness, which helps us to show the connectors between different groups of people. And you'll notice that certain individuals jump out quite prominently when we turn that on. And we can use a technique like PageRank, of course made famous by Google, and that helps us to understand the influencers within our data set. Now, Luca mentioned also that a core use case for OrientDB and a core use case for KeyLines as well is in visualizing physical networks, computer networks, complex systems of servers, networking infrastructure, and so on. So this data set here consists of exactly those types of components: servers, virtual hosts, services, and here we mean services in the sense of different software services, servers, and more. Now what we've done here, as we hover our mouse over any individual item within the visualization, we can see other items light up in red, and that's showing you things that are impacted by any one thing that we select. We can also, for instance, again, size our data relative to how impactful it would be within the overall architecture. We can also choose an individual item and have everything else fade into the background, and again use some of our different layout capabilities to understand the connections between them. So here, for instance, in the radio layout, we're showing degrees of separation away from the SAN unit 0, which if the SAN unit 0 were to go down, everything else that we see here would be impacted: first degree, second degree, third degree, and so on. Excuse me. Now, another area that we are very often concerned with is we're presented with a complex set of data to begin with. And it's a set of data that at first glance, we may see certain kind of patterns within the data, but it becomes difficult for us to understand. And what we'd like to do, ideally, is actually to combine the effects of a graph visualization with something like an aggregate or a counting of data in different categories. And so to do that, we have a feature in KeyLines called combos. Now, this is a data set of communications between terror suspects, and you'll see that what we can do, again, to provide a visual clue, is we can actually swap out the kind of common circles that we've seen so far in our visualizations with flags representing the countries that the individuals were living in. And as I zoom out, what I'm going to do here is I'm going to leverage, again, one of the properties of the nodes, again, using the multi-model capabilities, and I'm going to combine these by country. So now we see that we've got a combination of the graph showing the connections between individuals in these countries and the aggregate. So we've got the counts of the different items within those categories. So we notice, of course, Afghanistan is our most prominent within this data set, France our second, and so on and so on. So we've kind of summed up the individual items within any one particular country, and we've represented them at the country level. And if we want, we can in fact go one level higher than that and sum things up by region in this example. It's important to understand that this hierarchy is something that you can actually control and manipulate within your own data, and you can leverage that to, again, provide the visualizations in exactly the way that you want them to be. Now, I've shown a couple examples where we've leveraged different information about the nodes themselves or about the edges, but what if you actually just want to dig into those? In KeyLines, we do have what's called tooltips, and with these tooltips, we're able to do things like hover over different entries, and we can see or explore that information. Of course, we could actually manipulate this display in many ways that we want, showing it other places on the screen or embedding more information here, or in fact even going so far as to embed a hyperlink or any other type of functionality that you might want in order to explore more information about that. Now, Luca mentioned that geographic routing and navigation is, again, one of the core uses for OrientDB, and it's something that we see very much with customers of KeyLines as well. So let me just zoom in one moment again and kind of introduce you to the data that we're showing here. This is the flight network for the US as of 2014, showing direct flights between airports. So here you'll notice different airport codes like PHS for Phoenix, DAL for Dallas-Fort Worth, OKC for Oklahoma City, and so on. And you'll see, again, here as we select any individual airport, we're fading airports that do not have direct connections to those airports into the background. We're still containing them within the visualization layer. And you'll notice that what we're able to do is, of course, we're able to filter here by airline. So we've again used different properties of the data in order to create a set of filters. And we're able to use those same properties to create a color coding system. So you'll notice that, all of the American flights are kind of in a light blue, while the Alaska flights are in a dark blue. Now, of course, Airports actually have a geographic component to them. They have the location where they are. So if I pivot this from the network mode into the map mode, you'll see that we're able to leverage the latitude and longitude data and show these on the map. So why is that interesting? Well, again, we start to see certain clusters of colors arise. So for instance, here on the left, I'm seeing a lot of blue. I'm seeing more orange here on the right-hand side. And sure enough, let me just kind of clear things out for a second. And you'll notice that Alaska is a very dominant airline in the western part of the country, but does not really overlay with the orange section on kind of the right-hand side of the map. So Alaska doesn't really serve the east coast of the US effectively. And in fact, if I choose another airline like JetBlue, you can see that the effect becomes even more pronounced. So again, making tools like the ability to select or selectively choose which data is displayed in the visualization can be very, very important to your analysts in order to for them to get the insight that they're looking for very quickly. Other things that we can do, for instance, are leverage the frequency of the flight patterns. So here I can just use the slider, and I can, in fact, let me just add a few more airlines back. And now I can see, for instance, all of the routes that have more than 2,800 scheduled flights per year. So if I'm looking for what are the busiest connections, I can continue to play around with that. And it helps me to understand, the frequency of the flights, or to understand, for instance, that there are several thousands of flights a year between Anchorage and Seattle, or whatever it may be that you're looking for. Finally, one last demo that we'd like to share with you is a demo data set of the bike sharing system in and around Boston, Massachusetts. So, whoops, excuse me, I've zoomed a little bit too far in, perhaps. So in this data set, each of these nodes represents a bike share station where you can pick up or drop off a bike. Each of the lines represents a trip from the station where the bike was collected to the station where the bike was dropped off. And you'll notice that in this example, we've actually combined that again with the temporal aspect. So we're showing the time when that rental happened, when that ride occurred. So with KeyLines, we can, for instance, narrow our focus to a certain period of time. We could also do that by week, or we could again expand out, depending again what it is that we're most interested in. Other things we can do with the visualizations, we can color code our stations depending on the volume of traffic that they see during this time period that we've selected, where here the darker colors are the most busy stations and the lighter colors are the least busy stations. So if you're a city planner or you're somebody who's responsible for planning out new stations, this could be very helpful in understanding, where is this bike system being utilized the most? Where might we need to add additional stations around, for instance, some of these very dark purple color points? Or where might we actually have excess capacity within the network that we could look at either reducing size or potentially eliminating? And on a daily service basis, we might most be interested in information about which stations are gaining and losing the most bicycles, because at the end of the day, the stations that have lost the most are going to need to be restocked, whereas the ones that have gained the most probably have bikes that are not locked up properly that need to be collected and redistributed. And if we're interested in patterns like usage, we can again try to understand how our users have been using the system, where they're making the longest trips, and so on. And we can actually zoom that from either side. So if we're looking for a specific amount of time, trips that take exactly 25 to 45 minutes, we can zoom down to that level. We can also, if we're looking for individual things specifically, we can also zoom into certain dates, certain time periods, and we can see what's happened. And in fact, we can kind of play that out. So we can see when these trips are occurring, and the directionality of them. So that concludes my demos, and that concludes my part of the presentation. I'm going to pass it back over to Ed and Andrew for any Q&A.
Well, thank you very much, Luca and Jeremy. That was very interesting, both of you. I learned a lot through both of those presentations. So I'd encourage people online, if you have any questions, now's a great time to put them in. We've got a couple in already. So I've got a question for Luca here, and there'll maybe be a slight pause when we mute and unmute things, so please be patient with us. So Luca, the question for you is, how does OrientDB compare to, and they've given two specific examples, to Neo4j and MongoDB?
Thanks for the question. Actually, it's a very good one. So as we've seen in the quadrant when I was presenting, you can even say that OrientDB is like Neo4j plus MongoDB. So it combines the characteristics of MongoDB with the flexibility of documents, with the fact that you can use JSON documents, but on top of that, it adds all the characteristics of Neo4j and allows you to connect documents between them using direct links. So we've seen in Jeremy's presentation, for example, where we had a graph and every vertex and edge needed to have attributes. So the fact that you can connect a JSON document to a vertex and edge is like being able to use MongoDB plus Neo4j together. So the idea was exactly marrying those two technologies and having a product that allows you to use the document interface as well as the graph interface. So again, to make it simple, in some cases, customers decide to use what it's called polyglot persistence, so different databases to solve a single problem. We believe in multi-model, so one database that can solve multiple problems, and MongoDB and Neo4j are basically two of the leading technologies in the document space and graph space, and we marry their functionalities together in a single product.
Thank you very much, Luca. That was a great answer. Okay, I've got a couple of questions for Jeremy now. So Jeremy, the question is, I really like the demos you showed. Can I reuse them in my application? How would I get the JavaScript source code to do that?
Yeah, thanks for that question. All of the demos that I showed are actually available on our evaluation website, and I neglected to mention that we actually do offer free evaluations of KeyLines to anybody who's interested. You can just get in touch with us either through our website or via email, and I think you are seeing my email address on the screen. Feel free to reach out to me directly if you like, and we can help you get set up with an evaluation copy of KeyLines. With that, you'll actually have access to all of the demos that I showed today. And in those demos, and I apologize for not showing this as I was going through that, the source code for all of those demos is available. So a lot of our customers find it very helpful to use those code snippets to kind of help them get started as they look at using KeyLines for their specific needs.
Thanks a lot, Jeremy. Okay, another question here, and Jeremy, I'll pass it to you. So the question is there a way to show the shortest path between two nodes? And also, can I customize nodes with images and other information?
Yep, so the answer to both of those questions is yes. KeyLines actually has a function called shortest route, and in fact that can be tweaked to either be a route depending on number of hops or distance or time, depending what it is that you're looking for on the shortest route. And again, on our website, we do have a demo of that specifically that I didn't get to today. So you can use the different properties of those edges to help you calculate the shortest route that you're looking for, depending, again, if you're looking for time or distance or what have you. And the second part of the question, can I customize my nodes? Yes, very much so. So you saw in the one demo scenario that we were changing the nodes out for flags representing the country of the people in question. But you could, for instance, use somebody's avatar. You could use their social media profile picture. Whatever it has, whatever you have that you can tie to the node for representation purposes, you can definitely use those images as your to represent your nodes in KeyLines.
Great. So hopefully that was a great answer, Jeremy. Thanks very much. So I think we've got time for maybe one more question, and this is also for Jeremy. The question is, I really like what I see from KeyLines, but please can you explain how it is different from the open source packages which are available?
Yeah, that's a great question, thanks, and we do get that quite a lot. I think there are a few key differences, really. So I think as I've tried to show with the demos, one difference is that, of course, you can fully customize every aspect of the visualization using KeyLines, node styling, link styling, layouts, and more. And what we see there with a lot of kind of open source or other approaches is that in order to achieve exactly what it is you're looking for, you really have to work through the source code. So you'll end up essentially forking the package that in question and really having to work through kind of line by line. One of the core differences with KeyLines is that we've taken a little bit more of a developer-oriented or developer-friendly approach, where we've taken all of those kinds of decisions about how you might change layouts, and we've turned those into API-like function calls. So you don't need to wade through nearly as much code. You don't need to really go line by line. You kind of, with KeyLines, you kind of call the functionality that you want, whether that's a different type of layout or whether that is, rendering the nodes or the edges, together with the options that you want. So you might say, lay out these nodes and use this icon set. And that would kind of be achieved as a function call with KeyLines as opposed to customizing the source code of KeyLines. And I think that's one of the main differences that we see. And then finally, in the email demo, I showed a little bit of this. With KeyLines, we actually bundle some of the logic that we see most commonly used by our customers into the visualization layer. So that's, again, things like different social network analysis algorithms, PageRank, centrality, eigenvector, things like that. So you don't actually have to build queries or specific functions into your application to manipulate the data in different ways to do those calculations. You can get that from the visualization layer.
Excellent. Thank you very much for a comprehensive answer, Jeremy. Okay, so I think we have a few more questions, but I think we have no more time, and some of the questions are rather involved. So I think we'll call the session towards an end. I'd like to thank very much Luca for his time, and thanks Jeremy. A reminder that the session has been recorded, so you will get an email tomorrow morning with a link to the recording. So thank you very much for your time and attention, and good evening, good afternoon, wherever you are in the world. Goodbye.